Water is nature's most precious and priceless gift to all living beings on this planet. Life depends on water, and there is no alternative for it. It not only quenches our thirst, but is essential for the growth of flowers, fruits, food grains, and the production of fiber, fuel, etc. The demand for water has only increased with the modern lifestyle and the present-day industrial requirements. In other words, water plays a pivotal role in all walks of life. Ancient civilizations flourished beside perennial rivers, and even today, urbanization, agriculture, and industrial development are found close to natural or man-made water sources like rivers, streams, and tanks. The availability of water is an index to the development of an area. In peninsular area, aquifer groundwater has been overexploited. The same is the case with the water from rivers and reservoirs. Hence, the hot summer months are a period of trial for the urban and rural people, the wild and domestic animals, as well as plants. Groundwater reserves are overexploited when people draw out more water than has been replenished in that year's monsoon. This imbalance has made the availability of water from the deep aquifers in the summer months even more difficult. Water is available on the surface in rainy season. During this period, it should be collected and conserved. National water policy too has emphasized the need for conservation of this scarce and priceless resource. In central and southern India, a steep decline in the availability of groundwater is a major problem. The solution for this problem is to adopt integrated techniques of artificial water recharging and conservation of ground aquifers. In this region, rainwater is the only source of water, and it is available only in the 2-3 months of the monsoon season in a year. Two main techniques of speedy artificial recharge of groundwater or aquifer by rainwater have been adopted. Technique of water spreading, technique of water injection. The water spreading technique being adopted on a large scale in Madhya Pradesh is known as the Indore method of water conservation in and around fields. For conserving rainwater in and around cultivated fields, bunds of 50 to 70 centimeter height are made around 1 or 2 hectares of land. Soil for the bund is obtained by digging a trench along the bund line with a depth of 50 to 70 centimeters and a width of 60 to 75 centimeters. Depending on the slope, 1 meter length area is left undug at a distance of 30 to 35 meter to serve the purpose of a bund in a trench to help impound or hold water in each section. Moreover, at the center of the trench, a deeper pit is made, exposing subsoil or muram through which water percolates down to accumulate in groundwater reserve. Runoff water from the fields which collects in the trench gets time for deep percolation so as to get conserved in the soil aquifer. Soil from the field brought by the runoff water gets accumulated in the trench and can be returned to the field during yearly cleaning and maintenance work. The indoor method of water conservation in this way helps to conserve soil, nutrients and organic matter in and around fields. To enhance the percolation of water into the soil, there should be a provision for trenches in afforested areas. A distance of 15 to 20 meters should be maintained between the trenches. On hillocks and slopy ground, digging of trenches along the contour is desirable. Trenches may be filled with available biomass and covered with soil. Biomass on decomposition serves the purpose of plant nutrition and also it is useful in wasteland development. Moreover, because of porosity, water percolates down. In flat land area and in the strips along the roads, shallow saucer-like beds are useful in increasing water percolation. Swale not only increases water percolation but also accelerates the rate of growth of the plants. Certain industries at Devas have successfully used the pile or column method in open grounds or parking places for artificially augmenting the rate of water recharge. Round holes of 25 to 30 centimeter diameter and a depth of 3 to 4 meter is piled by an auger at a distance of 3 meters. 1/3 portion of these piles is filled with coarse pebbles. The middle portion is filled with medium-sized pebbles of 2 to 3 centimeters. And the upper 1/3 portion is filled with bajri. Rainwater collected in the ground percolates down at a faster speed without any obstacle to get accumulated in the aquifer. Piles or columns are useful in augmenting the percolation rate of water from areas where the soil has become compact and also from areas where silt has accumulated. It is necessary to collect the rainwater of a particular area in its own watershed on the surface or in the aquifer of that place. It is possible to achieve this objective. College of Agriculture Indore and Wheat Research Station Indore have taken up bunding in drainage channels or trenches. We can deepen the nalas by cleaning it and using the soil, boulders and muram found in it to make check dams. The velocity of the flow of water can be checked or brought to zero velocity by check dams at regular intervals. If at a particular point water velocity is high, at that point a stone slab or boulders and a wire net are used. By this simple and cost-effective technique, it becomes possible to conserve field and village water on the surface in the trenches or nalas which gradually percolate down to aquifer reserves. Adoption of this technique has registered a 3 to 4-fold increase in water output from wells to tube wells. Rainwater from a watershed flows out from a point to join a river. To keep a village water in that village itself, old ponds and tanks should be maintained and fresh tanks should be dug. By the adoption of this technique on a large scale, it has been possible at several places to maintain the groundwater table. At the same time, conservation of water on the surface for a longer time keeps the environment humid and makes water available to wildlife, birds, and aquatic creatures.
In the peninsular region, several thousand dug wells or say wells are available. If these wells are utilized for a collection of water, rainwater, then we can increase the availability of groundwater. For that purpose, we have developed indoor technique of groundwater recharge through dug well.
This technique comprises of channelizing the runoff water into a silt trap tank trap filter of pebbles and biological filter of vetiver or cusk fitted to the pipe leading to the well. The pipe is covered by a wire mesh over which a sand bath filter is provided. Water passes through the 3 to 5 millimeter size particle sand, which form a layer of 50 to 75 centimeters, followed by layers of small, medium and big size pebbles, each 30 to 40 centimeters thick, to enter the well bottom from the top. Filter could be horizontal or vertical. Water directly enters into the groundwater aquifer, which raises the groundwater table and simultaneously revives and rejuvenates old wells by increasing the water availability 3 to 4 folds. The advantage of this technique is that the water entering the wells is free from pollutants and is fit for irrigation and potable purposes.
In the basaltic region, groundwater recharge is a problem because in the basaltic region there are various layers of withered and basaltic rocks or rocks which are very hard, which are very impervious to water, and water cannot penetrate deep into the aquifer. The only way out for such purpose is to make use of this tube wells for recharging during monsoon or rainy period. It can be done by various techniques.
The major techniques are roof water harvest to fill tube wells, tube well perforated casing pipe with filter, tube well recharge by injection method. Underground reservoirs are an ancient heritage of Kutch, Gujarat and Rajasthan. The rainwater collected or harvested from roof is filled into the tank. This method has been revived at the College of Agriculture, Indore, and by the industrialists of Devas and Manglia near Indore. Roof water from residential areas, office buildings, godowns is collected and channelized through pipes passing through filters of nylon net and glass wool and allowed to enter directly into tube wells or wells and the deep aquifer strata. Hydraulic pressure created because of the water column, in fact, is useful in the percolation of water into the deeper strata of the aquifer. From the second shower onwards, rainwater is the purest and free from pollutants, and it is as good as distilled water. In industrial areas, pollution is a problem. To keep groundwater free from pollutants, the use of roof water to artificially recharge deeper aquifers is the best strategy. A cylindrical pit of 3-meter diameter and 3 to 4-meter depth is dug around the tube well casing pipe. In the casing pipe, holes of 8 to 10 millimeter size at a distance of 3 to 4 centimeters are drilled. Alternatively, an old casing pipe is cut, and at the cut end, a perforated pipe with additional holes is welded. On the perforated casing pipe, coir rope is wrapped, which serves the purpose of a filter. The coir rope needs to be replaced once in 2 to 3 years. In the pit around the casing pipe, pebbles 30 to 40 millimeters is filled in the lower 1/3 depth, followed by medium-sized pebbles 15 to 20 millimeters up to 2/8 depth. In the 1/3 upper portion, sand of 2 to 4 millimeter size is filled. Runoff water getting accumulated round the tube well passes through the sand bath filter and finally enters the tube well bore through coir filter, directly reaching the deep aquifer strata to recharge it. Water used for recharging should be free from pollutants, chemical and biotic biomass, or else it adversely affects the quality of water. Pure water from rivers and wells free from colloidal suspension could be pumped or injected into the tube well deep aquifer with the help of motor pump and a pipe reaching up to 50 to 60 meters depth. It may be used depending upon the location and at a place where the groundwater has been overexploited. Gradual environment degradation has been found to adversely affect average rainfall, and at the same time soil erosion too has affected water holding capacity and water conservation potential in several areas. Overexploitation and sole dependence on deep aquifer reserves has resulted in a steep decline in the water table level in several regions of the country. To raise the groundwater level, conservation of water in and around the fields and impounding of village water in a village is essential. A package of artificial recharge techniques needs to be adopted in the peninsular basaltic region of Gujarat, Maharashtra, Andhra Pradesh, Karnataka, Tamil Nadu, and Madhya Pradesh. In fact, this is the urgent need of this modern era, for if nature's precious gift is conserved and used judiciously, every farmer and his farm located in rain-fed farming area can get the benefit of development, and at the same time an adequate quantity of water can be spared for industrial use. To achieve this goal, our strategy should be to seek greater public participation. Plenty of quality water available all the year round alone can keep our planet, Earth green and safe for living beings.